Hello everyone, in this video I am going to discuss how to find oxidizing and reducing agents. So what are the oxidizing agents? Oxidizing agents are elements are in its highest possible oxidation state. Elements are in its highest possible oxidation state. For example, potassium permanganate. In potassium permanganate, manganese has +7 oxidation state. +7 is the highest possible oxidation state manganese can have. So that potassium permanganate always going to reduce, and it is the oxidizing agent in redox reactions. Likewise, potassium dichromate, nitric acid, H2SO4, hypochlorite acid, those have the highest possible oxidation state. Therefore, they are oxidizing agents. And also molecules made up of electronegative elements like oxygen, ozone, fluorine, always oxidizing agents, and they are going to reduce in reactions. And oxides of metals and nonmetals like magnesium oxide, copper oxide are also oxidizing agents. And fluorine is the strongest oxidizing agent. What are the reducing agents? Reducing agents are the elements are in its lowest possible oxidation state. Example, ferrous sulfate, oxalic acid and hydrogen sulfide. In ferrous sulfate, iron has +2 oxidation state and it's the lowest possible oxidation state for iron. Therefore, it is a reducing agent. And all the metals are reducing agents. And hydroxides are reducing agents as well. HCl, HBr, HI. And organic compounds such as formic acid are reducing agents. Now let's look at how to identify oxidizing and reducing agents. What is the theory behind it? So each half reaction, I have discussed this earlier, I am not going to repeat it. Each redox reaction has two half reactions. So each half reactions makes up a redox reaction has a standard electrode potential. Each half reaction has a standard electrode potential. So that is called as reduction potential. That is called as reduction potential. And this potential is measured with reference to the standard hydrogen electrode. That reduction potential is measured with reference to the standard hydrogen electrode. In this diagram, this is a setup of the measuring standard electrode potential of zinc electrode, and the zinc 2 plus 1 molar zinc 2 plus iron solution, salt bridge, and this is the standard hydrogen electrode in 1 molar H plus iron solution. The standard conditions are 25 centigrade and 1 atmosphere pressure. And now we can measure the standard electrode potential or the reduction potential of zinc from this voltmeter. So from that we can measure the standard electrode potential or the reduction potential of zinc electrode with reference to hydrogen standard electrode. The electrode undergoing oxidation half reaction, we call it as anode, and the electrode undergoes reduction half reaction is called as cathode. For zinc, standard reduction potential is at the standard conditions is minus 0.76 volt. For copper, it is plus 0.34 volt. When the reduction potential is increased, it is a good oxidizing agent. As the reduction potential gets increased, it is a good oxidizing agent. In zinc copper electrochemical cell, copper is the oxidizing agent because copper has, from these two, copper has the higher reduction potential. So it is the oxidizing agent. So it undergoes reduction because oxidizing agent undergoes reduction. And the zinc is the reducing agent because it has the lower reduction potential. Zinc is the reducing agent and it undergoes oxidation. So higher the reduction potential, it is going to reduce. It undergoes reduce. Higher the reduction potential, it undergoes reduce. Let's see this example. Redox reaction between permanganate ion and iodine. Standard reduction potential for permanganate ion is plus 1.510 volt and standard reduction potential for iodine 0.534 volt. These values are its standard values from the electrochemical series. So our rule is higher the reduction potential, undergo reduction. So what is going to reduce here? Reduction potential is higher in permanganate, therefore reduction permanganate ion. And oxidation, therefore iodine. And in this example, reaction between iodine and chlorine, standard reduction potential for iodine is 0.534 volt and standard reduction potential for chlorine is 1.359. So our rule is higher the reduction potential, it undergoes reduction. So chlorine has the higher standard reduction potential, therefore chlorine undergoes reduction and iodine undergoes oxidation. I hope this will help you. Thanks for watching.